In February 2026, a subtle but important shift appeared in global AI usage data, according to figures reported from OpenRouter. 4 of the top 5 most used large language models in a key weekly ranking were developed by Chinese companies. Collectively, those 4 models accounted for more than 85% of the total API calls among the top 5 within a 3-week window. Their combined usage reportedly expanded by roughly 127%. This development deserves a careful analysis, because this is not a research benchmark. It is not a leaderboard based in academic performance. It reflects real-world API traffic, and API traffic is a proxy. For commercial deployment, the companies cited in the ranking include Minimax, Moonshot AI, Jipu AI, and DeepSeek. These firms have pursued a strategy that differs in emphasis from the frontier model race historicized by U.S. labs, rather than maximizing benchmark dominance at any cost. They have focused on optimization for deployment, lower inference cost, competitive latency, long context windows, and suitability for workflow automation. In other words, engineering efficiency over frontier supremacy. This distinction is critical. For the past several years, the dominant narrative in AI has centered on model intelligence, who builds the most capable reasoning engine, who leads on multimodal integration, who tops standardized evaluations, but commercial adoption follows a different logic. Enterprises evaluate cost per token, latency under load, integration flexibility, and reliability at scale when a model becomes good enough. For customer service automation, document analysis, code assistance, and internal process optimization, then marginal gains in benchmark superiority may matter less than marginal reductions in cost. If inference pricing drops significantly, volume can expand exponentially, and volume changes the structure of the market. If this trend persists, 3 structural implications emerge. First, global inference demand could accelerate. Cheaper models encourage broader deployment. Broader deployment increases token consumption. Rising token consumption drives demand for compute infrastructure. Second, application layer companies may experience valuation re-rating if AI capabilities became economically accessible. SaaS platforms can embed automation at scale. Margins, productivity, metrics, unservice models shift accordingly. Third, pricing pressure may intensify across the global model ecosystem. High-cost frontier providers may face downward pricing tension. If lower-cost alternatives capture a significant market share in non-frontier workloads, however, several caveats are necessary. The reported ranking reflects activity within a specific aggregation platform. It does not represent the entirety of global AI traffic. Frontier, multimodal research, advanced reasoning benchmarks, and high-performance GPU supply chains remain heavily concentrated in the United States. Moreover, geopolitical and regulatory factors continue to shape hardware access and cross-border AI deployments. Therefore, this moment should not be interpreted as a definitive technological reversal. Instead, it may signal the emergence of a second competitive axis in AI. The first axis was intelligence. The second axis is cost efficiency. If AI evolves into infrastructure closer to electricity than to experimental research, then cost curves may become more decisive than raw capability curves. February 2026 may not represent the end of a race. It may represent the beginning of a pricing cycle, and in technology markets, pricing cycles often reshape power structures more quietly and more durably than headline breakthroughs. The question is no longer only who builds the smartest model. The deeper question is, who can deliver intelligence at the lowest sustainable marginal cost? That is where the next phase of competition may unfold.